Good morning. I guess we don't have too many newbies here. Anybody really new at Postgres, or are you already used to using it? Okay, so hopefully we'll find some tips and tricks that might be useful for you. So I'm Eric Lenve. I'm actually usually very busy with the Seattle Postgres user group. I work for a company called Deltek, which is in Virginia. I'm a senior principal software architect there. And I developed now for over 30 years, did many different SQL backend databases, but I'm a full stack engineer, so I do lots of web apps and so on. I used to do lots of desktop apps as well. The most challenging aspect that I found when people are trying to move to Postgres was the same thing for me too, is how to deal with just basic administrations, how to deal with the schema subtleties of Postgres, what are the restrictions and capacities that we're dealing with, of course, some syntax specific to Postgres, and gotchas and performance issues, and I'll go through some tools. So I created a document, which I will share the link through this. It's actually quite lengthy. If you print, it's like 23 pages long, and it covers like 25 different topics. So in theory, we should be going like almost like one or 2 minutes for each of them very quickly. I will not go through that pace. I will basically go to each of them and let you ask me any questions you have. Or if you have any feedback, feel free to do so. And so let me go straight to the document. So I made my life a little bit easier. As I said, I created a document to go through it first. It's going to be available as a link on a website I have called Harbor Wiki. And so I used the ChatGPT to create a lot of the content, but I found there were quite a few mistakes in it. First of all, we have to deal with versions. Sometimes it would provide information that was not relevant to what we currently have. And sometimes it would be confused about what kind of backend we're dealing with, and sometimes flat out wrong. But it's still a very valuable tool. So one of the first things that I always suggest people is use a good admin tool. I use pgadmin most of the time. I know some people use dbeaver. Some of the key advantages that I found in pgadmin is that when you actually use it and you create a schema or you tweak your settings, you can usually do a right click and generate script. So you can actually see what is necessary for you to do. So I would highly suggest you to use PostgreSQL, pgadmin to do this. Also, you can access multiple versions of your Postgres servers. And if you have any questions on this, or I can just skip it for now. Okay, I'll just skip it. As I mentioned, we have a few alternatives that exist. pgmanager is actually created by the host of this conference. It's a Java application, so if you're into Java, this might be a good option for you. Otherwise, dbeaver is very popular. And I also have an application which I created called DataWharf, which I will be speaking a little bit later on today, which is actually a database modeling tool, which is for multiple backends. But I favored Postgres. So if you want to actually reverse engineer a schema, do modeling through diagrams, kind of like Visio-like diagrams I use in Draw.io, you can use as well. Again, these topics I'm speaking about are mainly targeting new developers to Postgres, so they can be at least aware of what exists. If you're already using those, this is kind of redundant. One of the most common tools also spoken about is called PSQL. Now, this is a command line interface. I hardly ever use it personally. I know it can be very useful if you are on a non-GUI interface, like if you're basically in Ubuntu or Ubuntu in Docker, then this can be kind of your only choice. But otherwise, most developers have a GUI, so most of the time, we don't need to use it. It also seems that pgadmin is being maintained actively, and every time they add new features to PostgreSQL, you're going to have a feature supporting it in pgadmin. The one little caveat I have found difficult with pgadmin is security setups. Configuring security in Postgres is kind of a nightmare. There was no easy way for you to say, what kind of access actually do I have here from all the inheritance? There is no good modeling for that. Okay, the next thing is you'll find there is a database when you install PostgreSQL called Postgres, all lowercase. And some of you may wonder, what is this for? I would say the golden rule is don't touch it. It's a default database that's available there for you. It has some settings that are there by default. It is owned by the super user role, so it doesn't have anything. But I would say the big advantage of using it is that if you are cloning a database, copying a database, you can anchor yourself on the Postgres database in pgadmin. So if you put yourself on Postgres, you're not setting up a connection. So if you try to kill a connection and you are on the database, you're already on it. So how can you actually do maintenance? So the idea is that place yourself on Postgres database and do your maintenance from there. The next item that is usually confusing for developers is the word schema. Schema is used for everything. It's used for your structure of your database, but it's also used in Postgres as a true container, which I usually call a namespace. So they call it, Postgres calls it a schema, which again is a structure. So get used to the terminology is very important. When you say schema, schema of what? My schema of my structure or the schema database? So it is organized. I've got a little print screen here. You can have, would you like me to go and show you pgadmin, or are you all familiar with pgadmin here? New? Okay. So in pgadmin, the structure, so I'm going back a little bit, you can have multiple servers. You set up your connections. So you right-click, set up connections. You have connections for Postgres 15 and 17. All of your databases will be listed in a major container called databases. You have all of them here. You have your Postgres database, which is the one I just mentioned, as one of them here. So when you want to work on it, use this little icon called Query Tool, and it creates for you an entry point. You can actually make your queries from there. So all of the samples in the document I have, when you copy-paste, this is where you paste them. Now, when you go to a database, it has by default one namespace called public. In Oracle, those are called, in MSSQL, those are called owners, usually. Here, so in the other databases, they are really tied up to a user. In Postgres, they are not. They are actually kind of like a folder where you have inside of them most of your other components, like the tables are listed under a schema. If you're coming from MySQL, there is no schema, there is no namespace, everything is flat. Now, you may wonder what is the advantage of the schemas. One, it helps you to organize and group different content. You could use it as a multi-tenancy when you want to create the same set of tables in different schemas, different namespaces for your different clients. So you could do that. So you can have two tables of the same name as long as they are in a different schema. The one big caveat, and I'll come back to my document here, and this is what I would definitely say you should look at this as a reference point afterwards. Be very careful with the schema called public. Now, public is the schema that is created by default, but it also means that all users have access to it. So if you have an app and your app is a very simple application like Data Wharf, I just use public because in any case, it's only the web app that accesses the database. You're not giving direct access to your database itself, so who cares? If on the other way, you're going to have multiple applications accessing your schemas, you probably should avoid using public. Okay? And by the way, this is how you would create your schema. Create schema, if not exist, and a name. I love the fact that in PostgreSQL you have that if not exists, so you don't get error messages, you don't block your scripts. They also have a concept called a schema search path. So if you try to access a particular resource, by default it's going to look for certain schemas. The default is public. Later on I'm going to speak about extensions. Extensions are installed into schemas. So even though you install an extension for a database, which I'm going to speak about if I get to there, you have to be very careful. If you don't have a public schema, you have to tell which schema to install your extension in. And also you have to deal with security. So you may want to leave the schema public still present for extensions. Just don't put your content into it. And again, when you access your table, since the same table or enumeration or whatever resource you want to deal with, if you have multiple schemas, you put your schema in front of it, so schema dot and the name of your table. As I said, you have to be very careful. So I've got little alerts here to be very careful about the public schema. MySQL doesn't have. I bring up the issue about schemas for Oracle and namespaces and MSSQL as well for you to be aware of. You can grant access, by the way, at the level of the schema. If you give access, full access at the level of the schema to a particular role, they have two kind of roles, user role and group role, user groups kind of, that's going to take over all of the other access you have. So be very careful to not give full access at the level of the schema unless you really intend for that user or that group to have access to everything. Now, it would also mean that the super user has access, of course, to everything. I basically have listed for you some of the commands you may want to use to basically set up your access rights, grant, remove. You also have a usage. So even if you try to give access right to access the select command or insert or update, you first have to give usage access. It's like, hey, I want to connect to the schema. Then you can also access. That's why I was mentioning that PG admin is a little bit weak on the sense of security. Now, as developers, usually we just use Postgres, you use super admin user, and we're done. But if you are a developer who has to also provide access to additional applications, then you better be very careful about these access rights. There are tools you can use to actually query how the access rights are done. I didn't go deep into this. You can just look them up, Google them, or ChatGPT ask them, and you can have those. Some queries are available for you. Okay, field types. The list of the topics I'm covering, kind of jumping a little bit in all different aspects. I try to put the one that seems to be the most important as developers first on top. So I knew that to know where things are, how to actually see things are the most important. And then your field types. Because I work on data worth now for a few years, I had to ensure that I've got field type compatibility between all of the different backends. I support MSSQL, MySQL, Oracle. And I had to deal with the different field types. So Postgres, it's a very mature product that I actually started to code, I think, in Postgres 8, I think, early on. Took a break for a few years and came back to it. The most common field type is called text. So under the characters, you've got text. Text have no limitation of size. And then most people use varchars. In most backends, people don't use text. Be very careful, though, when you're using text. Text allows you to put carriage returns. So if you have an entry screen and you let people type in a carriage return, you may not be able to see them afterwards. So be very careful using text. I usually says, try to avoid using text unless you really meant it to be, unless it was a blob of some kind. Use varchars, usually. Now, the difference between varchars and chars, I would say the big difference between the two, chars will add blank space at the end. So now, the funny stuff is that even though when you try to fetch your data back, you'll have extra blank space at the end of your characters, and that's true in most databases, when you compare and you search, at least the query engine will kind of skip the blanks. So other backends, they will care about the blanks. Postgres does not. And then the limitation, the size of your characters, it really depends on the version of Postgres. Although I think since Postgres 11, it became fairly stable. We are dealing with characters, not bytes. So please be very careful about this. So I usually always set up my database to use UTF-8, which most of you are used to. In NC characters, 1 byte is 1 character, but as soon as you use any kind of accented letters, or if you use Spanish, French, or whatever language you use, you're going to use more bytes. So this is a limitation by characters. It also means you cannot put character 0. That's going to be a problem. So you have to be very careful about what you use. Now, the great thing about sizing, you can put one gigabyte of data into a text, which the other vendors usually don't have that. They're much smaller than that. So we'll go in capacity, you're going to see this is a big advantage. The maximum numbers of characters is 10 million, a little bit above that, which is more than enough. And it's again, the characters is again like for codes, I would say. If you use for codes, use that, otherwise go varchars. You can easily extend the size of a varchar. It doesn't cost you when you set up your database. Of course, if you reduce it, you may have a problem because you may already have the data in it. You may lose data. By the way, Postgres is fantastic at when you resize items or when you add a column. Adding a column with no default is instantaneous. It's like a metadata. In some other backend databases, it's actually going to go and rewrite and update every single rows. Postgres does not. So it's very fast. There's another talk being given, by the way, if you have the time, you may want to go to see it. They speak about performance and what they call DDL, which is the changing of your schema. If you have very large databases, what's the impact that might be of interest? Binary data, this is what I use quite often, called byte A. It can store 1 gigabyte. It's basically like the text, except it's not bound to a particular encoding like UTF. Very practical. You also have something called large objects. Now, large objects, it says you can store 2 gigabytes per object, but I thought you can be even bigger than that. Be very careful with this. This is a feature they added, I think, when they did not have proper support yet for the 1 gig limit. It is a series of stored functions that you can call to actually store huge blob. You upload a file, basically, or you fetch back a file into this large object, and it chains them together. The problem is, this is at the level of the entire server, not the whole database. So its limitation is based on that. Second is, you need to have almost a super user access right to be able to access those store functions. I would say, create your own splitting of the file and put them into byte A records. Rarely you'll go beyond 1 gigabyte, but that's basically what I do. I also store hash of my files, so I know where to find them or if I should compare them or not. Now the file size, I could not get a complete nail down of your capacity. Most places they say that the maximum database size is 32 terabyte, but it also says the maximum table size is 32 terabyte. I know it's not true for the tables already. The partition, you can take a table, partition it, break it down. When you create the table, you say how the partition is being created. And each of those partitions is 32 terabyte. Now, I never had a database of that size. I think the biggest I ever had was like 25 gig. If you do proper normalization, you shouldn't be having enormous tables. If you do enormous tables, you're not normalizing properly. You may as well use another database engine. Integers, small int, and big int, those are the three that are the most popular. Nothing special about them. The floating point, like in other databases, it may lose precision. So if you put some values into it, you may lose some data. So be very careful on those. The numeric are basically the one with the decimal point. You will have an error if you try to store something that does not fit into your structure. So if you have numeric with a 2 decimal point, you try to put 3, it's going to throw an exception. So this is actually, as a developer, is one of my favorite ones because I do want clean data. So either I go with integers or big int, or I go with a numeric. So I can specify the size. They also have field type like money and other currency. Again, if you're coming from other databases, you may want to stick with the most generic one. Okay? By the way, when you go in a PG admin, the numbers of field types that exist are exorbitant. You can actually create your own custom types. Again, if you come from another database and you need to maintain the other database, you may want to avoid those. You may want to stay generic. Something else called serial types. They're basically integer with a built-in counter. If you create an integer, you can specify a constraint to be actually an incremental. You can set up the step. I think if you are a serial, it's automatically 1. So there is no big difference, but you can use those. Date and date time. Many different backends exist again. The date, stick with it if you just need a date. If you use times, you have two kind of flavors. Now you have time and date time. I never saw the real use to have a time without a date. But maybe some people have it. If you needed some kind of difference of time, you usually use something called an interval, a difference of time. But otherwise, using a straight time without a date component, it's kind of unusual. If you use time, for a long time, I was still stuck with the old MySQL way of doing things, which is basically the time, whatever you send into it. One of the best features that I believe exists is something called time with time zone. Now you'll think, oh, you put time with time zone. Is it storing the time zone into it? Not really, but it's taking in consideration the time zone you are in and storing the time in a time zone independent fashion. Now when you query it, you can actually, and here are some examples, when you want to get the time, you can specify, hey, get me the time of my field as if I am in a time zone. So especially if you have a website and you're accessing this from many places and you allow users to specify where their time zones is, ensure that you use a timestamp, they call it timestamp, which is date and time, with the time zone turned on. It stores the times independently of wherever the server is configured, your web server, for example, so you don't have to worry about the admin set up the time wrongly on the server or being affected, or when they change the time zone of your server, you're all messed up. Again, if you stick with timestamp with time zone, when you query, depending if you like ODBC connection, it has a time zone built in, so you're going to fetch your time zone. Otherwise, you can supersede it and specify a different time zone. Now, this is another little cool thing about in Postgres. You can actually query the list of time zone it knows. There are over 100 of them. They have every single esoteric time zone you can think about. So if you want to know the names of all the time zone you have, take this query and execute it, and you've got up and running, you've got your list. In my web apps, I actually fetch this, and I make it available for the user to specify what time zone they want to be in. Because I provide this list from Postgres itself, I never have to be worried about them picking up a wrong time zone or getting an error of some kind. So again, very practical. Boolean, simple one. So here's the funny stuff. A Boolean is actually a whole byte. Now, they also have something, a bit type. Bit type is not the same as Boolean type. You may wonder, what is this? Again, as I said, Postgres has a ton of field type. A bit type, imagine, is basically a series of switches. So it's like binary, 10, 10, 10. So you can make a bit type of like 10 bits, and each of them are switches. Again, if you come from another database, why would you use that? Why is it necessary? Don't know. Now, if you are deep into Postgres and that's what you do, you may find reason to use it. Otherwise, no. Boolean, on the other way, it's a 1 byte consumption, so don't think that because you're using a Boolean, you're going to be using less. So very often I will use a small int or just an int, especially if you have, a status field like active, inactive. Guess what? Make it a numeric, because at some point your manager is going to say, make it also an option called discontinued. So that's why I try to avoid using Boolean, but you may want to use it. And you can use the word true, false. You have to be careful because by default, Booleans are nullable. So nullable are not the same as false. So you have to be aware of those, especially if you query. If you make a query afterwards, says, show me all the false, you're not going to get the null ones. And then, as I said, you have a bunch of way to test and or and not. Again, the nulls will not work. Please be careful here. Again, another tip. If you're using ODBC connectors, to be able to see the Booleans in your backend as a true or false, so it doesn't go into a numeric, because most ODBC connectors, they don't support Boolean. They will go and they will and it will convert it to you into a 1 or 0. So the funny stuff is you have to say, actually says bulls as char equals 0 will make it in, for example, .NET or whatever language you use, or Python, as a true Boolean. So a little gotcha here that can help you. Next field type, UUIDs. again, as I know I'm spending more time on these field types and I will be skipping some of those subjects, but this is, as a developer, I'm trying to go into the mind of developers and what is important. UUIDs. Oracle is now being very proud. They're finally going to be coming with it, I think, in a new version. I think MSSQL has it now. I don't remember. No, MySQL doesn't have to my recollection. But basically, the built-in UUID of Postgres, which actually existed for a while, is stored as a 16-byte internally, so it's much smaller than the 46 or 43 characters that the other one stores it in, because they store it as a text instead of as a binary. And you can actually see the default version of the UUIDs. The reason why you may want to build UUIDs is that why? For primary keys or not. I personally would only use a UUID if you intend to merge data from two sources together and you don't want to have a clash. Otherwise, you can have still a primary key as an int or a big int or something like that, auto-increment, and make it easy on yourself. One of the reasons why many people are avoiding UUIDs is because you could not sort them. They would be so scrambled that you could not see in which order they were added. Postgres 17 added a new version of the UUID called version 7. I wasn't able to confirm it working, by the way, on my version of 17, but it's supposed to be there. So you can actually have it generate UUIDs that are chronologically sorted. So if you list your table, and if you decide to use UUIDs as primary keys, they're going to be scrambled enough so people cannot guess what the next key is, but still listed enough so when you know in which order they were added. Because one of the big problems about using primary keys as the regular UUIDs is which order were these added in? Oh, I may add a timestamp field. Yes, it's one way of working it. But it's so much easier to just see your list of records that way. I often use a combination of the primary key as an integer because, by the way, again, the links can be faster. You're not dealing with 16 bytes here. You can be using with 4 bytes for an integer most of the time. So it means your indexes are smaller and it's faster still. But I use UUIDs for my web pages. So when I make a direct link to something, so to a resource, in the URL, I'm using UUID. So UUIDs can be very practical if you make a web app and you want to provide a URL. It's there. People do not guess about how busy or what the next record is. And again, you can use them. Well, by the way, when you create your database, you can specify as a default to create your UUID for you. Again, please be careful about which one you use to set up. I have a whole section in this document that speaks about the different ways of fetching or setting up UUIDs. Next item, JSON. They have 2 types of JSON, JSON and JSONB. The JSON used to be the original one, then they added JSONB. B is basically an enhanced version of JSON. So unlike the other backends, you can actually when you make a query, to make a query that includes a field, and then you can actually continue go deep into your structure of your JSON. You can actually even, in theory, build indexes on the content of your JSON. So most people will use JSON. I use JSON, for example, like for the data wharf. I've got these diagrams of all these objects, and I use the draw.io engine. And so I can actually fetch all of the position of all the elements in a JSON blob. I store that in JSON inside of Postgres, so it's easy, readily available for me there. And I can navigate through it. I can actually fetch it. So if you're using a web app, using the JSON option is very good. Next item to be very, very careful about. Every type in Postgres can be flagged as an array. And you may wonder, what is this? Basically, in one of the places I was working on, they were making arrays of UUIDs. They did not want to create a new table, so they made a field, an array of UUIDs. Be extremely careful for this. First of all, you're breaking the rules of normalization because you're storing more than one of the same content into the same field, which is actually breaking one of the rules. Second is, you cannot really make constraints on those things. Foreign keys doesn't work on an array. Now, you can make some complex constraints in theory, to unpack the arrays, to find into the arrays and get into it. But I would say avoid it as the plague unless if you have a real need. But again, if you're coming from another database like this speech is about, you probably are not going to use it. So don't go overkill on that one. Enumerations. Many people, especially, they already had enumeration. So enumeration in Postgres has its own type. It's actually a separate lookup of values. And you have a command called create type. You create a type of type enumeration. The enum type, the values are fixed. And this is what it's very careful. So don't get tempted about creating an enum like active, inactive. You could maybe add discontinued, but let's say that you want to remove one of your type. You can't. Supposedly they are working on it on an option to actually remove a type. In value, an enumeration value, but it doesn't. The second caveat is it's all in whatever language you type it in. So most people, they don't just deal with English. They want to have multilingual. The next thing about, they say, oh, but enum type is going to get constrained. Only if certain values are valid. It's true, but Postgres has easily a way to add a constraint on your field. So if you make a numeric type, when you create your type, you can still say valid 1, 2, 3, or whatever the value is. So you can put constraint after the fact. So performance-wise, same thing. Many people, if you're importing data from somebody else, they already may have used enum type. I would say as a developer, please be very careful on this. It is very practical. In Data Wharf, I manage those for you. I let you list them and document them because many people already had them, so I want to be backward compatible. In Data Wharf, I let you actually create enum type of type numeric, so it becomes a documentation tool. But otherwise, native enum type, please be careful. Now, internally, it uses less space because it's basically a binary being stored of the value, kind of like when you're programming in C, small piece of text for the big text. So it is good for that. But on the other way, you cannot delete. When you query, you always get the text, so you're stuck with the language. So let's speak about Postgres naming restrictions. Names, column, tables, schemas, index, enumeration, even enumeration values, they're all limited to 63 characters by default, unless if, I guess, you recompile PostgreSQL. But if you're using a cloud environment, you're stuck with 63. Beats me why it's 63. Now, you have to be careful for this because indexes, we'll skip here. Indexes are unique to a schema, namespace, not to a table. So when you create an index, even though the index only makes sense to a table, its name is not namespace to the table. So don't create two indexes of the same name, two different tables. You're going to be out of luck. So if you have a long table name and you try to have an index and put that name in it, you're out of luck. In Data Wharf, I actually create a UUID, and I make UUIDs for indexes that are too long so it can then fit in 63 characters. Be very careful for that. So characters, not bytes. So you could actually use some non-generic characters. You can even use blank space. You can even use apostrophes. You can use almost anything. I would, again, if you're using an ORM, avoid those as the plague. Most of the ORMs cannot handle the non-generic first letter, non-numeric characters, A to Z, upper, lowercase, and underscores. But even the blanks, I would say, try to avoid it. But in theory, you can do those. By the way, Postgres, by default, it's actually case insensitive to start. So if you create a table, like the word my table, up and down, you can query it with all lowercase or whatever you want. If you want to keep case sensitivity, you need to surround them with double quote. Now, I do that all the time because I use a framework Data Wharf which makes it easy for me. It makes it much easier when you're pgadmin to read all these things. Because otherwise, even though you may have to do a create with upper and lowercase, anytime you use an admin tool, you're not going to see your casing and you're not going to know where your words are. Now, again, if you use double quotes, you may have two fields, one with a different casing. So you have to be careful on those. But by default, it's case insensitive, which is actually stored as all lowercase. And I speak about the double case. Enumeration must begin with a letter and an underscore. So these I actually do have a constraint here. Table name must be unique within the schema. Column name can be unique within the table. Luckily, it's fine. You don't make a... So in theory, I know some people will put, for example, the vendor table, they will put a field called vendor ID. There's no need to put vendor there. You can just call it ID. Because anywhere you query, you can always call vendor.id. So, and you can always use the as statement if you make your query to actually put the name of the table and the column name afterwards. Especially if you're dealing with 63 character limits, if you put the table name in front of your column name every time, you're going to hit this limit much faster, especially when somebody wants a nice, clear name. Okay, maximum sizes. Nice thing, by default, up to 1,600 columns. Now, again, this is really if you have a need for it. So if you get some forms and you want to put all the fields into it, then sure. But otherwise, this is pretty ugly. I think the most I ever did was maybe 200-300 columns. Again, if you normalize properly, you shouldn't be going that big. But again, if you're using Postgres kind of like a big data store, which you could, because it is phenomenal for performance, then yeah, you may start to use a bunch of fields. You have to be careful though, again, your identifiers to be maximum 63 characters. Column limits type, again, see the information above. Your row size itself is 1.6 terabyte. So even though you can have a character or text with 1 gigabyte in it, actually terabyte, you're quite fine. You can have your hard hat, sorry, I forgot. 1.6 terabyte. But the whole table is by default 32 terabyte. As developers, usually that's not an issue for us. Okay, a duplicate an entire database. This, I remember when one of my peers was showing this to me. It was one of the best things as a developer I could do. How often do you wish you can make a snapshot of your database? And instead of making a whole snapshot like an AWS of your whole server, I just have a database. It's not that big. I just want a snapshot of it. So here is the trick. First of all, you have an attribute to your database called the connection. Allow connection true or false. So the first thing you do is you kill new connections to happen to your database. So you set, here I'm using DataWarf as one of my databases, because I make it uppercase and lowercase is between double quotes. Allow connection to false. Next thing, you may already have a bunch of connection on it. And this is, by the way, you shouldn't be doing this while you are on a database you intend to clone. Go on Postgres or something else. This command will basically query all the connection that exists, find its ID, and actually send the terminate command to all those connections. So now you have a database where nobody can connect to, and no connection exists. And here's one of the best commands. You're going to create another database with template. That database that has no connection on it can be considered a template. Now, when this occurs, it's actually going to do an operating system copy. So whatever media, most developers have an SSD hard drive, it's actually going to copy the internal files of Postgres for you. This is not a backup and restore, because most backup and restore will create equivalent SQL commands, and then all the commands have to be executed. It takes forever. This is a true image, and especially because you killed your connection, there's nothing happening in between. So you can actually have a true copy. And then later on, you can always do rename. So I do a backup, I put usually a date and time stamp, and I can always rename those. I can make them back active. Or I can take the one that I'm messing up and move it aside. Again, you can do your renames from your Postgres backend to rename your other one. So the renames will work even if connection is false. And at the end, of course, remember to turn the connection back. You allow connection to true. Now, this cannot be executed in a transaction, meaning the create database cannot be part of a function or stored function. It has to be done interactively. But again, as a developer, you know what you're doing. Okay, little trick, you want your size of your database. This is the command. I know you can Google it, but I just wanted to provide it to you. It gives you an idea, so when you want to make your copies, you kind of know how long it's going to take. The beautiful thing about Postgres, when you create a database from template, it's going to tell you how long it takes. And as I said, most of the time it's a few seconds, maximum a minute, because it's an operating system copy. Anybody has any questions to this point? Okay. All right. What is this one again here? Oh, if you want to see all of the different fragmentation. So in Postgres, it doesn't use a system to lock a record to edit the record. Every time a data is changed, it makes a new copy of the record for you. Now they call that a tuple. When a tuple is created, it still knows the internal identifier of the record, but also knows the connection that it was created from. The idea is by doing this, you don't have to log the record, and if you store the session information to your, not the connection, the session, you'll be careful. So when you're connected is one connection. A session is a series of steps you do. So if you do a begin or end transaction, most ORM is like a blink of an eye, everything is done in one shot. So the session appears and disappears. But if you're doing some kind of bigger transaction where you're trying to query items, those are called sessions. By the way, a little note about this. Be careful about, don't add a bunch of records in a session and query and expect them to see them. You're not going to see your new records until the previous session transaction is finished. So I think there might be some work around it, but I got caught a few times with this one. Make all your edits, make all your changes, and if you rely on querying those, make a new query afterwards, a new session basically, a new transaction. Now these, because of this session, because of Postgres not locking resources, but basically allowing to do all these writes at the same time everywhere, you're going to have these, what we call dead tuples. Basically things that are values of a record that are not anymore useful because when the session was created, no one else anymore has a session that old. Because again, the advantage of this whole session thing is that when you query database, your tables, and you have your one-to-many relationships, you're going to get the children that make sense at the time the session existed between the parents. You're not going to have some kind of weird orphan record because everything is branded into the session. But on the other way, you get these orphan tuples, records. Because of that, Postgres has a concept called vacuum. It's a way to recycle those dead tuples. As developers, sometimes you don't know when is this vacuum kicking in. A vacuum is kicked in at the level of the server, not the database. Which means that if you're doing multi-tenancy, many different databases, and one of the database has an incredibly long-running query that takes hours, the vacuum is not going to kick in. So also, sometimes when the vacuum kicks in, it's also when what we call the analyze occurs. The analyze is Postgres statistical analysis of what you have, how the data is laid out. And that is necessary for Postgres to do its queries. You may hear during these talks about something called the query analyzer, I forgot the word now, how it decides what index to use, which order it decides to use. It needs to know the statistics. Because of that, the analyze have to kick in, and that kicks in with the vacuum. This query will let you find out what you have. I just got notice I have only 5 minutes left. Before I go any further, do you have any questions on this? Let me maybe go on the top here and I actually at least list you what you can see. We spoke about, yes? No, go ahead.
In practical terms, how often do you actually need to analyze the contents of tables in order to have the query optimizer behave reasonably?
Perfect. Please, for you guys, go to this document, but you have some tips and tricks. If you add an index, which is on an aggregate, not on a straight field, that index is not added to the built-in analyze, which means that even though you added this fantastic index on upper of the case or whatever it is, you run your query still so slow, is because the query optimizer is not using it. Then as a developer, you need to manually start the analyze. And then you have a whole command, and I speak about in this whole section here. So you have explain, which actually will tell you what's being used or not used. But this is, again, when you would say, when should I use my analyze or not? 5 minutes. This could be hours worth of talks. Duplicate database, size, adding columns, default value. I mentioned already, if you add a default value, every single row is going to be updated. So be careful on this if you have big databases, otherwise it's instantaneous. This ticked on, please look at this. Other databases don't have this. It's a distinct, but instead of every column, it's certain columns. So if you want to find what is the biggest dollar amount of an order, and you have a one-to-many relationship, normally you would do a max on and a group by or a subquery. This ticked on, you can skip that. So the this ticked on paired with the order by, I got examples, will help you a lot. So this is a feature you can take advantage for you. Stored function, the whole section about this. The great thing about store function, I know the other databases has it, is you can say, run the store function under the creator's right. So don't give access to certain tables. The function can have access to those tables. So you can actually create like a virtual API of your database by using stored functions. Anonymous code block, an example, so you can actually create a bunch of steps and you don't have to create a store procedure. So if you're doing lots of manipulation work yourself as a developer, use anonymous code blocks. You can put any logic into them and you can run them without having to register a store procedure and execute it. Connection info, I speak about how you can actually brand each connection name and you can kind of query which app is running on which connection. Cool little trick. There is no if, IIF, you have to use case. There are 2 flavors of case. Please look at the documentation for that. I have a tool called Sign Audit. It's not me. Almost not known. This is going to add triggers to all of your tables and you can actually query what changed where. As a developer, this is fantastic. You're trying to trace down what was touched by your app. You can actually even brand a transaction, put a name or whatever, or a key, and find out all the records edited, or undo things. It's a really old tool, works very well still. Of course, I've got Data Wharf. I would highly suggest you using it. You can run multiple versions of Postgres on the same machine. As developers, we should always do that, because we are supporting one, run another one. The trick is use a different port. I speak about that too. Partitioning and charting. If you have very big database, one requires a developer's involvement. The charting does. Partitioning usually not. DBA kind of work, although if you're creating the syntax for them, you will have to do that for them. Parallel queries, fantastic. That's one of the reasons why AWS and many other vendors are dropping their MSSQL Oracle, because Postgres 17 now is actually 23% even faster than the previous ones. They're getting so much faster all the time, it's insane, because of this parallel query. And if you use the explain command, which I speak further in this document, it's going to tell you what it's doing in parallel or not. Ownership, whole section, please be very careful on this, because who can change what is based on ownership. The trick is, as a developer, don't give ownership to a person, give ownership to a group. And then you can play with that. Multi-tenancy, many of you do that. Unlock table, very good. You can flag a table so it's not written into its own log. So if you're using like a tracing of some kind, as a developer, you want a trace file. Make it fast, use unlock tables. Explain is how you can study your queries. Having clause, absolutely look at this too. You cannot use the as statement of a column. You know, you may do something count as total count. You cannot use a total count in your having. You have to be tricky about those things. Also the group by, there's a tight coupling between group by and having, which MySQL doesn't have. For your interest, foreign data wrapper, you can actually wrap MongoDB or MSSQL or Oracle, whatever, and have them appear as a Postgres database. Then you can copy things between them, and they appear as Postgres, even though not Postgres. Real cool feature. Extensions, a bunch of them. The most useful is for what I call PostGIS, for geographical information, or just for the UUID. And as I said, I have also a whole section about generating UUIDs. I will be adding more and more sections to this. The link to this document is going to be available in my talks sessions. I'm going to post the link there for you. You can reach me through LinkedIn. Search my name. You can connect me there, or I'll be here at the conference if you want this. Hopefully, this document is going to help you. I did this to not only help myself when I forget something, especially if I don't work on Postgres all the time, and hopefully it's going to save you some hurdles or know what to look for when you develop in Postgres. Any questions? Okay. Thank you.